In this intertemporal budget constraint, you can see that 1 plus r is a relative price. And in particular, that 1 plus r is going to be in units of goods in the future over goods today. So I want to emphasize that what the real interest rate is doing in this setup, and in any setup, is it's telling you something about the price of goods today relative to goods in the future. What we're now going to do is go into thinking about what interest rates do more generally. And this is about present versus future values. So compounding converts values today into values in the future, whereas discounting converts values in the future into values today. So let's suppose that you borrow money, and here initially we're going to talk in terms of dollars. Let's say that you borrow money today, and that's period t, and you pay it back over the next 2 years. That would be in periods t plus 1 and t plus 2. And we're going to let big R be the nominal interest rate. So 1 plus R is the gross nominal interest rate. So if the interest rate is, say, 6%, 1 plus R would be 1.06. If we take the payment that you make tomorrow, xt plus 1, and we divide it by 1 plus R, what that does is it converts dollars at t plus 1 into dollars at t. Then we do the same thing for dollars at t plus 2, except now we've got to divide it by 1 plus r twice, essentially. So the first time takes dollars at t plus 2, converts them into dollars at t plus 1, and then we convert it from dollars at t plus 1 to dollars at t. And that gives us what x2t is, which is the present value of this payment xt plus 2 periods from now. So then the total size of the loan is just the sum x1t plus x2t. And that's just equal to the present value of this payment stream, which is payments at t plus 1 and payments at t plus 2. So xt then is just what's called the present discounted value of the payments xt plus 1, xt plus 2. So a numerical example, if the nominal interest rate is 12%, and we want to ask what is the present value of $100 payments for the next 2 years, and then a $200 payment in the third year. Well, what do? We're going to get a $100 payment next period, divide that by 1 plus r. $100 payment 2 periods from now, you have to divide that by 1 plus r squared, and then you get a $200 payment 3 years from now, and you're going to divide that by 1 plus r cubed. So you figure out what those things are equal to, and what we see is that the present value of $100 next year, $100 2 years from now, $200 3 years from now, the present value of that is $311.36. So what role does R actually play? If the nominal interest rate rises, then future dollars become worth less, and this then reduces the present value. So capital R is the opportunity cost of a dollar. In other words, the nominal interest rate is the opportunity cost of $1. So a higher nominal interest rate means that a given number of dollars today are worth more in the future. So we can think about big R as a relative intertemporal price. And in particular, 1 plus R is equal to dollars at t plus 1 divided by dollars at t. Of course, you can just multiply this through, and if you take 1 plus r times dollars at t, you get dollars at t plus 1. Or you can rewrite it a different way, and you can see that the present value of dollars at t is equal to dollars at t plus 1 divided by 1 plus r. Now, analogous considerations come into play when thinking about the real interest rate. Now, the real interest rate is a relative intertemporal price, but it's in terms of goods. So 1 plus little r is in units of goods at t plus 1 over goods at t, or as I wrote it before, goods in the future divided by goods today. And then you can just go through the same manipulations of this formula, and you can see that the value of goods at t plus 1 is equal to the value of goods at t times the interest rate. Or alternatively, the present value of goods today equals the value of goods in the future divided by the real interest rate.